Today we'll be talking about another problem, very similar to the prefix sum problem that an earlier video covered. And this problem is sort of a variation. And by its name, if you've seen the other video, you can kind of tell that there is going to be some pre-processing involved. So again, let's use the example, the same example from the other video with this array. But instead of the queries being the sum of the subarray, let's say I want a query to be adding any number or to the to a given subarray. So for example, if I were to say add 1 to this subarray, the end result would be 4, 8, and 5. And so again, if we think about it the brute force way, we would just iterate through every single element in that subarray, adding the increment, and then finally that takes O of n time, which again brings us to another O of n times q time complexity problem, very similar to what we did before. And again, there is a solution that takes n plus q time if we just do a little bit of pre-processing. Now, this is a little different. And how do we get to, and remember, in order to get this q time, we need the queries to take O of 1 time. Since there are q of them, q times 1 is just q. So an idea would be, again, to take some pre-processing time and add a secondary array to help us. One thing that we can think about is that no matter how many times we change it, we really don't care. We don't really need to change all the elements of the subarray until we've finally had no more queries. So instead of iterating through all the elements in each subarray, we can just maybe mark down somewhere that this subarray has been changed. So how do we do that? Well, let's think about what we did in prefix sums, right? So we had a secondary array to keep track of sort of any changes that we want to do. And so from here, let's use the example I gave earlier. Basically adding 1 to the 3, 7, 4. Well, we're only dealing with this little portion of the array. So we can say, let's start adding 1 here so that in our final run through, we would compare this starting array with the change array. Let's call this C for the change array. And every time we encounter +1, the rest of the array will have 1 added to it. And then if we keep going, well, I did say that we're only adding 1 to this subarray. So how do we make it so that this 1 doesn't apply to the entire subarray? Well, that's where the previous solution comes in handy. Again, you see this red line is basically this blue line minus this green line. So we see the same pattern again. We can basically say that adding 1 to this entire blue line and then adding 1 to this red line, we have to kind of cancel out the, and of course, this part, it should cancel to 0. We don't want to modify this part. So if our blue line is just +1, our green line has to be -1 for it to match. So if we look down, green line, there we go. So we have a +1 and a -1 here. And so let's give another example. Let's say we want to add 3 to, I don't know, 4, 2, 5, this subarray. Again, we can add 3 here. And you notice that from our previous +1, it compounds on top of it. Since if we were to just accumulating the sum, we would get the +1 and +3. So the 4 would correctly go to +4. And so again, in this case, we have to subtract 3 here. Okay, so when it's all said and done, let's see the final array. Okay, so we start off with 1. There's no changes, so that's 1. And then maybe it would be easier if I were to fill in the C array. So it starts off with no changes. You get +1, and again, the +1 carries over from the previous video. And so +1, +3. So this would actually become +4 because we have to do 3 + 1. So this becomes +4. -1, it becomes +3. And then nothing. There you can think of the empty boxes as 0, so it's just +3. And then now we are back at 0 since the -3. And so this little auxiliary box here is just for easier to like implement in code-wise, as you will see later. So we have 3 + 1, which is 4, 8, 8, 5, 8, 6. Yeah. Remember earlier in the video we added 1 to 742, so that's should be 8, 5, 3, and then added 3 to sorry, 374. We added 1, and then we added 3 to 425, and so that is accurately represented here. Cool. So now that we have that in mind, let's do the actual code. Here's the problem statement. Given an array of n integers, AI process Q queries where the ith query adds 1 to all array elements with indices between Li and Ri, inclusive. Print the final array after processing all queries. Okay, so as usual, here's the template that we have. First line contains 2 integers, n and q, so with the same changes as last time. Let's change this to q, and then add in an n. Cool. So before that, we have to read in our input. So let's read that into an array. And then let's keep track of a prefix sum array, gamma size of this one. Okay, so our input takes queries here, 1, 2, 3, 4, 5. So we could just do let's do a for loop to read that all in. Okay, now that we have our array, let's do the, in this case, solve. We would have to pass in again our sum array. Cool. So we actually want to initialize this to 0. Let's do that. And then for each query that we're doing, let's read in the left and right values. And here we actually have to subtract 1 from each to fit our array. And then all we have to do is to do the prefix sum. So the sum, in this case, we are adding 1 to all array elements. I know I said that we can add any number, but I mean, in this question, it's just 1. So we'll say the sum of the left will add, and then as we saw before, the right +1 needs to get the subtraction. Okay. So after we finish all of that, we can print out the updated array. So let's get this. So firstly, we have to add the previous array. So we have to, or basically, we don't have, if I is 0, do nothing. But if it's not equal to 0, we have to make sure that we add the code for the previous. Sorry, now that we have that, we could now just print the updated. Remember, our psum array is really our change array, and that's what we're adding to our. Okay. Yeah. So let's show you. Yeah, I've actually already pasted the test input in. So let's see if we can compile it and run. Okay, so I should have space between them. Let's try this again. Okay, 35666, and let's see, 35666. Oh, well, it matches. And again, to just double check, let's go ahead and submit this file. And there we go. It's accepted. Well, that's all. Thank you for watching.